Good evening, everybody. Welcome to our wonderful building, Hamilton Place. For those of you who have not been here before, do have a look around. It's a wonderful building. And welcome you to what's going to be a fantastic evening. It really is a pleasure to have the support of the DG of European Space Agency. As Howard said, I'm the current president. I've got to say that I've got some space experience. I've worked with ESA in a previous role, and it was my pleasure to go to ESTEC on a regular basis, which was, I have to say, geek heaven, if I'm allowed to say that. So it really was a great experience, and I have tremendous respect for ESA as an organisation. So the Royal Aeronautical Society is the only global organisation serving the entire aviation, aerospace, emphasis on space community. As a learned society and as a professional engineering institution, we've got a legacy going back 150 years, not in the space sector, but we are independent, evidence-based and authoritative, and that seems to be particularly important at the moment, where the truth is contested sometimes. So I think that's going to be a key selling point for us in the future. If you're not yet a member, I would highly encourage you to become a member. It's definitely an organisation where the more you put in, the more you get out. So I'd encourage you to get involved, and hopefully this evening will leave you with a positive experience. Space is a major theme of the society, and it's certainly the professionalisation of space is one of my presidential themes this year, and we as a society have been trying to look at what we mean by a space professional. And also there is the need to look at the sustainability aspects, which is another society theme. And we're looking forward to, and I need to get the acronym right, the Earth Space Sustainability Initiative. And there is a conference on the 26th of June. Is it here? Yeah, that's here. Which will be the first major update on ESSI. And it will be preceded by the Sustainability Conference on the 24th and 25th of June. And I think the advert is that bookings are already open. So with that, I'll hand over to Howard to introduce our sponsor. And thank you. Enjoy this evening. Thank you.
Thank you very much, David. So we are very happy to have Sarah Macken, the Chief Executive Officer of Telespazio UK, who have very kindly sponsored our cocktail event, which is taking place after this lecture. If you'd like to come and say a few words. Thank you.
Thank you, Howard, and thank you, everyone. Good evening. So I'm from Telespazio UK, as just mentioned, and for those of you who haven't heard of us before, Telespazio is very much in space services, still downstream. And what we do is we take the data and we bring space to life for our customers. So we process it, take it off the satellites, and put it into the hands of institutional, commercial, and defence customers. And I'd just like to say that it's really great to be part of this programme in the ESA ministerial year, which is a very important initiative and something that the UK is part of. And there are just two missions that I'd like to mention, which I think have a real significance for the UK. So the first is called Truths, Traceable Radiometry Underpinning Terrestrial Studies. Oh, I think, there we go, I got it. So it's a little bit of a mouthful, but what it's essentially will be, once launched, will provide more accuracy to climate missions and more precision. And you might say, well, why do we need more precision? Well, I can tell you that the climate modelers are really looking forward to getting the data from this mission, because when it comes to managing and mitigating the impacts of climate change, precision will be ever more important. So it's a really important and significant mission. And the second one that I'd like to mention is Project Moonlight. So Telespazio has had a great history of being involved in all sorts of Earth observation missions, science missions, and now we're part of a project to provide lunar communications and navigations on the moon. So it's a project that was kicked off at the last ministerial. We hope that it will receive the injection of funding that it needs from UK, from the many other participants. So we're really pleased to be part of that with our parent company, Telespazio, from the UK. So we're very proud to be part of a fantastic and vibrant space industry. We're very excited to be supporting this event this evening, and we hope you enjoy the drinks afterwards. So I'll see you at the reception. Thank you.
Thank you very much, Sarah. So now I'm honored to introduce our speaker this evening, Dr. Josef Aschbacher, Director General of ESA, an international organization today with 23 member states. Born in Austria, Dr. Aschbacher studied at the University of Innsbruck, graduating with a master's degree and a PhD in natural sciences. He's accomplished an international career in space, combining more than 35 years work experience in ESA, the European Commission, the Austrian Space Agency, and the Asian Institute of Technology and the University of Innsbruck. As the Director General of ESA, Dr. Aschbacher is responsible for the definition, implementation, and development of Europe's space infrastructure and their activities, which include launchers, satellites performing Earth observation, navigation, telecommunications, and space science, together with robotic exploration and ESA astronauts working on the ISS, the International Space Station. He's responsible for an annual budget of 7 billion euros and responsible for more than 2,500 staff members, as well as 3,000 contractors distributed across the ESA establishments in France, Germany, Holland, the UK, Italy, and Belgium. When taking up office as Director General in 2021, Dr. Aschbacher published a new strategy for space in Europe called Agenda 2025, aimed at accelerating significantly the use of space in Europe through major new initiatives and programs. So, Dr. Aschbacher, I would now invite you to come up to give us your very interesting lecture.
So thank you, Howard. Is this working? Yes. So thank you, Howard. Thank you, David, and of course, Sarah, for the cocktail invitation afterwards. Very happy to be here. Royal Aeronautical Society is a very prestigious society since 1866, which is quite remarkable, and I've actually looked a little bit into the history, and it's really something very special where the UK and of course the Royal Aeronautical Society has really achieved a lot over the many years of activities. ESA, we are a bit younger, but we do have a celebration this year. We are celebrating 50 years of the European Space Agency, having been founded in 1975 based on a number of activities that were before a research organization and a launcher development organization. They were merged and ESA was created out of it. And the UK is a member of the European Space Agency from the very beginning, a founding member of ESA, and therefore really a very active member. So what I've put together is a number of slides to give you a bit of background of what we do, but what I also look forward is a bit of discussion afterwards of what are the larger strategic orientations, where do we go, what are the challenges, and some of it is not on the slides here, I can assure you, but certainly the discussion I think is also a very important one. So where do we start? What is ESA? Just in one slide, who we are, but it was already introduced by Howard, so thank you. We have 23 member states. Since the beginning of this year, we have a new one, the 23rd member state, Slovenia, which was joining just recently. But we have all the member states or all the states in Europe which have a major space capability as a member of ESA. This includes some of the member states that are not a member of the EU, like the UK, like Norway or Switzerland. On the other side, we do not have yet, as a member, smaller countries like Cyprus, Malta, or similar states which are not yet a member of ESA, but we do have association agreements with those countries. The budget was mentioned. We have about a bit more than 7 billion this year. It changes, but it has been increasing over the last years, so it's really something where member states collectively have recognized the value of space for society, for the economy, and in the future, I assume more and more for security and defense, because space by nature is, of course, a dual-use technology that serves a variety of applications and uses across the board. If you divide this 7 billion or 7.7 billion by the number of people in our ESA member states, you end up with 15 euros per citizen per year. 15 euros per citizen per year is not a lot of money. It's the price of a cinema ticket. It's the price of a coffee and a croissant. Depends a bit on where you are, but it's really not much. But if you compare it with a cinema ticket, ESA is delivering good cinema for these 15 euros per year in terms of science, technology, and applications that we are funding. We are by far the largest research organization in Europe which is doing projects themselves, funding, but also doing the projects ourselves through our project management. And we spend about 60% of all the ESA, of all the public funding, in space in Europe. So we are, I would say, the big elephant in the room, the big organization which is working on the space activities in many, many domains. Let me show you some of the things that we do. What you see here is a slide that shows deliverables of 2024 or delivering successes. And when I'm asked by journalists, when I'm asked by the public, what are you doing in ESA? How do you function? And what is the organization like? I sometimes say just two words: we deliver. We deliver success, we deliver space hardware, we deliver satellites, which we produce, which we develop, of course, with our industry, with our member states, and we then launch them, we operate them, and make sure that space technology is utilized. I'm not going into the details of these satellites that we have launched last year. This is 2024, so only 1 year. But just to say that 13 satellites have been launched. They're all different. They're all major developments. Some are very complex. I take EarthCare as an example, which is a very complex mission to study climate, to better understand our Earth system. I mentioned Hera, which is a mission that is going to an asteroid to explore how asteroids function and how, if an asteroid would ever come to our planet Earth, what we would need to do in order to protect ourselves so that we are not hit by an asteroid and we don't have the same fate as dinosaurs 60 million years ago. So there we are really testing technology for humankind in order to preserve or to protect our own planet or our own species on this planet with the technology we develop. Of course, Galileo, Copernicus missions, we have launched quite a number of them, and really some missions are quite outstanding. But what you also did last year is we had the first flight of our big rocket called Ariane 6 on the 9th of July, and I will show you afterwards a small video clip from that, but this was a big milestone. It was delayed when I became Director General of ESA in 21, as you mentioned. I got a number of dossiers on my desk when I entered the office, and they said, look, these are the problem areas, these are the ones that you really need to tackle and spend a lot of energy, a lot of time to sort it out. And getting the Ariane 6 rocket to the launch pad was one of them. There was a big file with a lot of things in it. I can tell you there was huge work needed to resolve technical problems, to get the partners working together, which was not the case at all when I was becoming DG of ESA, but making sure that we stabilize the schedule, that we stabilize the problems and really make it. And last year, in mid-July, we had this inaugural flight. I'm sure many of you have probably seen it in the news and probably seen it even live on video. This was a very important moment. 13,000 people across Europe have been participating in order to create and to develop this rocket. Last week, we had another launch successfully, the first commercial launcher with Ariane Space as operator, where we launched a spy satellite as a customer, as a payload on top of the rocket, and worked very well. You see this smaller rocket next to it called Vega C. This is the medium-sized launcher. Again, there we had to bring it back to the launch pad. We had one flight in 2022, which was successful, and the second flight failed. And then we had to redesign the engine, we had to retest it, we had to procure other parts, we had to basically get it back to the launch pad. And again, this happened last year, so we had the big rocket and the medium-sized rocket again in space, and therefore we have now guaranteed access to space, which is fundamental for any space agency. Of course, we also have astronauts. We have last year flown 2 astronauts coming back from the space station, one from Denmark, one from Sweden. And you see the pictures here, Markus Wandt and Andy Morgensen. We have also graduated 5 new career astronauts, and we have opened a facility in the astronaut center called Luna, where we simulate situations on the moon's surface with a facility where we can actually have regolith and see how we would work eventually on the moon once we are putting again astronauts back. What you see on this graph here is actually a number of deliverables, and I can say this was actually more than what NASA delivered last year. With 3 times the money, I think we are proud that we have, or with 1/3 of the money, I should say, for ESA, we are proud that we have really delivered a lot. This year will be equally busy. What you see here is the highlights coming up this year. I mentioned the member state. Not going into the various elements in detail. Maybe I just want to point out one figure which is quite remarkable that you see here in the very middle of it. 1,500 contracts. This is the number of contracts we are typically signing each year. Last year we had a similar number. This year we will have a similar number than last year. And this means if you divide 1,500 by 200 working days, by 8 hours per day, on average, we are signing 1 contract an hour. So it shows that we are an agency that is, first of all, defining the work packages. Then we are preparing the tender documentation, which is a bit of work to make it precise. And Sarah was just mentioning some of the missions. You can imagine how much work there is to describe what we want to achieve. Then industry is preparing a proposal, which also takes quite some time. There's a lot of intelligence, a lot of technical knowledge built into these proposals. Our experts are evaluating those proposals. Then we identify some points of negotiation. We negotiate with the company, and then once we agree on all the points, we sign. So this is a chain that is quite significant, and we are doing the whole cycle every hour on average. So this is really a major work that we have to define all the work packages and then make sure that all the puzzles and all the pieces and all the contracts are fitting together. This shows the ESA budget. We have been mentioning the ministerial conference. Of course, no money, no honey, so we always need to make sure that our activities are well funded and therefore first of all, well defined and are very attractive. What you see here is the countries' contributions. This is this year's budget, 2025. The numbers are not exactly the same every year. It depends a little bit on how much UK contracts we have this year. Sometimes it's a bit more, sometimes a bit less. And based on these contract values, we then call up the money, which was, of course, committed some years earlier. So you see the UK here, and I have to go closer to read it myself. It's at 6.3%, 6.3% of the ESA contribution, which is solid, but could be a little higher. But I will talk about this a bit more, saying that the UK GDP value is higher than the 6.3% compared to the other countries. If you look here at other countries, take France, Germany, Italy. These are the long bars in the blue color and the red color. Of course, the UK has a similar size economy, a similar size strength of technical expertise and knowledge, quite a lot of excellence in artificial intelligence, in quantum technologies, in space technologies, and many related domains. And I think this is something where I would cordially invite the UK, of course, to make sure that this capability is well suited, is well introduced in the European context, and therefore really, of course, the ministerial conferences subscribe to these programs. How does our ministerial work? It's actually quite an unusual way of organizing funding. Normally, you would think if you are a member of an organization like ESA, depending on the size of your country, you pay your share. And if that would be the case, the UK bar would be, of course, much longer. But this is not the way ESA is working. ESA works very differently, and I've worked in quite a few places, but I've never seen this somewhere else. It's quite unique. About 20% of our budget is provided to ESA based on the size of the economy. So that is really the GDP of a country. But the other 80% of our budget is what we call optional programs. Optional meaning that we define a project, let's say a satellite mission. You mentioned Truth, you mentioned Moonlight. We define a project, and then we put it on the table, and we invite countries to subscribe. If the UK thinks this is strategically important, they put more money. If the UK thinks it's less important, they put less money or zero. You can also put zero in some projects, and you do not need to participate. So it's a very open, flexible system. It's very powerful because it really allows each country to define those domains where they are good, when they have excellence. But of course, it also does not oblige a country, and therefore you can do more or less depending, of course, on the priorities you have or on other considerations, sometimes economic situations at large. So this is the way how we work, and this is the way how we do. So we need to be very attractive in terms of defining programs and projects in order for a country to subscribe to it. Otherwise, they wouldn't put money on it. But it works very well, this system, because we also have a guarantee that once a country puts the money there, that we guarantee that the money is going overall back to the country through a system of open competition. There's a very fierce competition for each contract, but overall, we guarantee that minus the cost of ESA, of running ESA itself as an agency, that we give the money back to the country. And this is a very important principle. It's a normal principle, you would say. I give you something, you expect something back. And this is the way how we function in ESA. So therefore, the more you put in, the more you get back through a competitive process where we make sure that the best companies at large are selected at the end of the day. This is in terms of funding, the portion, how it is spent. So the previous slide was the income side. This is the way how it is being allocated to activities and projects. I'm not going into detail, but just to say that we are, first of all, doing all the space activities you can imagine, from astronauts to navigation, communication, Earth observation, space station, Moon, Mars, universe exploration. We do really all the domains you can imagine. You see here the share of how much we do for what. By far the biggest is Earth observation, where also the UK is very strong and very good. But you also see navigation, communication, space science are major programs where we are actually allocating quite a bit of funding. This is an interesting curve. And this now really shows Europe in comparison with the United States. So what you see, the European budget is the blue line at the bottom. One is the member states only. The other one is total. Total means also income, for example, from the European Union. And you compare this with NASA, which is one league above, so much higher, much more funding. The NASA budget, at least today, is about 25 billion euros or dollars, almost the same amounts. But what you also see, in the United States, the Space Force budget has increased extremely fast. It was created in 2019, actually by the Trump first administration, and the funding has really been increasing very fast. And this shows that in the United States, on the public side, both defense and civilian budgets, NASA and the US Space Force, there's about 5 to 6 times as much funding available to companies and to different players to build space programs. So that is a bit of a handicap, and this is something we need to rectify, and I want to rectify, certainly for Europe. We have managed in Europe to lift up the funding. It's probably not so visible in this small scale because the scale is dominated by the figures of NASA. But at the last ministerial conference, 2022, we managed to get 17% more compared to the previous one. 17%, sorry. 17% is a lot, especially if you think of 2022, when we just came out of COVID, when the war in Ukraine started a few months earlier, and most countries had double-digit inflation figures, all conditions that are not very promising, not very good to collect money, but still we managed extremely well to increase our budget. And also this year, last year we are really increasing our budgets constantly, but at a much lower level of course, compared to the United States. This is the same graph, but showing slightly differently. What you see on the left-hand side is the budgets, again, global space budgets of public funding. So that is NASA, ESA, JAXA, and other space agencies. And you see here, the United States has about 60%, more than 60% of the global space budget. Europe has 10%. China has been growing, has been increasing over the last years to a figure around 13%. The figure of Europe, and this is not only ESA, this is Europe altogether, including UK national funding, including the European Commission, including French and German national funding and other funding sources. So Europe has 10% of the total global space funding. That is not enough. That is something that needs to be changed, where we need to work on it. Also, and that this is the bad news I have to tell you, the same diagram 5 years ago actually had a similar share for the United States, around 60%, but for Europe it was 15%. 5 years ago, Europe had a global share of 15%, today it has 10%. Because China has been growing, Japan has been growing, the United States has been growing, so faster than Europe. And this is a message I'm giving to my decision makers, that this is not sustainable and is not good for our companies, because we risk losing the best people, and we risk not being able to really build up strong space programs. Having said that, despite the moderate means we have, it is remarkable what Europe is producing with the small, I would say, limited amounts of funding. Because in some programs, we are the world's best developers of space programs. I'll give you 3 examples, and they are not small ones. In Copernicus, we have the best Earth observation program in the world. Better than NASA, better than China, better than Japan, better than India or anyone else. With satellites, quite a lot of them, which are observing our Earth every single minute, the atmosphere, the ocean, the polar regions, the land surfaces, and how they interact and how they work, with a lot of applications that are derived from it. In Galileo, in navigation, we have the best, most accurate navigation system in the world, called Galileo. More accurate than GPS. GPS was created more than 20 years earlier, in the 80s, in the 80s. Europe in the 90s decided to, although GPS was available for free to everyone, or at least most people, Europe decided to develop its own navigation system in the 90s, and slowly started building it up. Today, it is more accurate than GPS for a fraction of the price. And that this is something where Europe can be very, very proud of. Another example is space science. Space science means observing the universe, so really the quite exotic observations. I'm sure you know the James Webb Space Telescope, where Europe actually contributes 1.5 out of 4 instruments. But also Euclid is a European mission looking at dark matter and dark energy, something very obscure. All of the things we see here on our planet, David would know very well, our planet Earth, all the stars, all the galaxies, everything we see and we measure with our telescope is only 5% of our universe. The other 95% is either dark matter or dark energy, which we don't measure. Why is it dark? Because we cannot measure it. For example, the universe is expanding from the Big Bang, but it's expanding faster than, it's not expanding regularly, linearly, but the speed is increasing. So there must be an energy that pushes it, expands it faster. We do not know exactly what this energy is. We call it dark energy. And we have launched a mission called Euclid, which should look into other indications in order for us to understand why the universe is expanding faster, where the energy may be sitting, and how this all may work. Quite fascinating, but Europe is in this domain quite leading. We have some of the best space science programs in the world. Together, of course, we are working with other organizations. So Europe is good, small, but really good and really strong. So this year is a key year for Europe's future in space. On the right-hand side, you see ESA Strategy 2040. You have mentioned Agenda 2025, which was the policy document which I put on the table when I became DG of ESA 4 years ago. Now we are developing the next level of strategy. We call it Strategy 2040, which is not only a 4 years time frame as we have usually done in ESA, which was usually linked to the mandate of a Director General. But now I've proposed to make a longer-term time frame, so until 2040, the next 15 to 20 years, and endorse it by member states, so it's much more stable, long-term, and certainly something that will survive different DGs and different political streams and priorities, but really something that guides us for the medium to long-term future. You see on the bottom left, ESA EU coordination. The European Commission has a new commissioner for defense and space. And that is a huge change compared to the past. The first time that a commissioner has in his title or in her title space and linked with defense. I don't need to explain why, but this is certainly very important that I can say that ESA is working very closely in this domain. And talking of the UK here, or in the UK here, this is certainly something where I hope we can explore commonalities and cooperations. Don't need to refer to the more recent happenings in the last couple of days, but certainly something that will drastically change the way how we work in space in Europe altogether. And this is certainly extremely important. We have the ministerial conference at the end of the year. You see here in Bremen, which happens to be every 3 years, hosted by the presidency. At the moment is Germany. This is certainly the moment where we put again our optional programs on the table for countries to subscribe, following the system I explained before. You see on the bottom right something that may not sound very exciting, but I can tell you is absolutely fundamental for us to be ready and fit for the future. ESA transformation. I've started the process about 2 years ago. My colleagues working in ESA with me will confirm that we're turning ESA a bit upside down. That means we really change ESA, make it faster, more efficient, more dynamic, leaner, and we are de-bureaucratizing, if I may call it this way, our agency, making sure that we are well equipped to interact with industry or with our member states. It's a long process, it's a deep process. Believe me, this is probably the most difficult of all, but something that needs to be done, but we keep moving forward. It's not something that starts on the 1st of January and is done on the 31st of December. This is an ongoing process, but something that we have really initiated and we are working on together with various stakeholders. Let me say a couple of words on the sites and establishments. I think you mentioned it, Howard, at the beginning. We have different countries where we have big establishments. We have a workforce of about 6,000 people across different places. And there's one establishment in the UK, and I'm very happy and very proud of our center in Harwell. We have established it a bit more than 10 years ago. And this is a very important activity where we have about 130 people working today. I have committed together with the UK Space Agency to increase this center from roughly 130 today to about 200 at the end of the decade, based on projects, based on joint interest that we together build and that we together build up. It's not only me, ESA, this is really together with the UK as a country, represented by the UK Space Agency, that we really build up these activities. You see here on the slide what we are doing. It's on the Harwell campus. There's several thousand people in the surrounding, and we really would like to make sure that we are well connected to the activities in the surrounding, obviously being the mini ESA, if I may say, in the UK, also part of ESA, obviously, but also connection to the other parts. But really I would like to build up the activities there. There's so much excellence and expertise here. I would like to further increase the UK as a major space partner within the ESA family. Is a very strong one, and this center certainly is one tool, one element where we will materialize it. But of course I should say that when we work with the UK, we work from all the centers, from ESTEC, from ESRIN, from all the centers we have, but certainly the UK center has a special standing in this. This is the impact that has been measured based on the last ministerial in 2022, where the UK put about 2 billion euros, 1.9 billion euros into the subscriptions of ESA. And in addition to getting the money back, because this is what we do, that we guarantee that the money comes back through industrial contracts, through competition. In addition, these are the figures that have been calculated based on real fact figures. That means this is done based on work that we have produced and that the impact that has been created. I'm not quoting them here. You see them on the screen, but it's quite remarkable what this has created in addition to getting the money back. So this is really additional economic activity, but also jobs that have been created over these years. And this is something that space is typically doing. We are, of course, contracting a company, but then other companies are being created, other domains are being served through the services. These other companies are paying taxes to the government and so on. So this is really, of course, a cycle where we have a multiplier effect depending on the domain, but this multiplier effect is sometimes 3, sometimes 5, sometimes even more. I've heard of one case, this is not applicable here, but the Arctic Weather Service had a multiplier by producing better weather forecasts for Arctic countries, northern countries, and the economic impact was 53, which was quite remarkable in this particular case. So these are some of the examples where the UK is really good and really strong. The UK is a very strong space power, a very strong member within ESA. I really can say, and I'm very happy, also very grateful, but very happy to say that UK industry and UK research organizations, UK users are very well integrated and using a lot of these space technologies. So what you see here are some of the satellite projects or some of the projects where the UK is heavily involved. We have heard Sarah before talking of some of them, but there are quite a few companies, big and small, that are working on our projects. Earth observation is certainly a priority of the UK. You see here RAeS, which was a fantastic mission which measured wind, speed, and direction in cloud-free atmospheres. Quite remarkable how it was done, a very big laser technology that nobody in the world ever has mastered. NASA has tried twice to build such a mission and failed twice. China tried once and did not manage. So Europe was the only one mastering this technology. It has been launched in 2018, had a lifetime of 5 years, is now deorbited, but we are now building a second one because it is such an important mission to improve weather forecasts with information which otherwise you don't get. These cloud-free wind measurements are quite unique. But also biomass and forum. Other missions on Earth observation, you see Vigil, which is a mission on space weather. Quite interesting that from the sun, flares are coming out. They are threatening our infrastructure, either in space or on ground, electric grids or other very sophisticated components. And we want to measure, we want to have a warning of a couple of minutes before they enter, or a couple of hours, I should say, before they enter our Earth atmosphere and therefore create damage. So therefore, this Vigil mission, where the UK, by the way, is leading, is a very important one in this regard. Galileo, also the UK is quite well participating. Other examples are here on science. This is participation on the James Webb Space Telescope. We also have other missions like Plato and Ariel. Aero is the Earth Return Orbiter. ExoMars is a very, very interesting mission which will be launched in 2028, flying a rover to the Mars surface, drilling into the surface, analyzing the material which is obtained from drilling 2 meters down into the ground and seeing whether there are old traces of life that we could see. Old life, maybe still existing life. We do not know what we see under the surface of Mars. But certainly, if you want to find life outside this planet Earth, there are some places where exobiologists are telling us you should look at. One is Mars, but not on the surface, because the surface with all the cosmic radiation has certainly no life forms existing anymore. But maybe there could be forms of life underground, and this is why we have ExoMars drilling into it. Or other places to look for would be, or could be, one of the icy moons around Jupiter or Saturn, which have huge oceans, more water than our oceans on planet Earth, which are under thick ice layers, about 100 kilometers thick. And there could also be life under these ice layers in these oceans. So we do not know, but certainly something we would like to investigate. Of course, the UK Very famous also for the astronauts. You see the 3 candidates that have been selected in November 2022. I'm sure you know them all very well. In the middle, you have John McFall, who will be the very first what we call para-astronaut, an astronaut with a physical handicap that could fly to the space station. We have done a study. We have qualified him to be able to fly. Of course, now we need to find a flight opportunity, but certainly quite unique. And he happens to be a UK citizen and also a very popular one and a very nice one, as you know. Other examples of the UK in telecom. One interesting example is RAeS, not RAeS Square, but RAeS, which is a mission where we work with telecom operators to optimize routes for flights, for airplanes. We have a contract with EasyJet and ITA Airways from Italy to use this technology to minimize carbon footprint. That means carbon emissions, and to gain time and make sure that the routes that are being selected are optimized based on information coming from various sources. And obviously, telecom is playing a key role in order to communicate and to make it work. Technology developments, space transportation, also launches. The UK is quite active in creating a launch pad. Saxaford is one which has probably a bright future. Some micro-launcher companies are trying or having arrangements to launch from there. Also, there are micro-launcher companies in the UK which are quite active, Orbex being one of them, and very interesting activities. Altogether, the space economy is quite booming. Let me say one word on, so you see some examples here where the commercialization is going very fast. But overall, today, we have a space economy that is about $500 billion worth. This space economy is projected to grow to about 1.8 trillion in the next decade. If you just take a linear curve from 500 billion to 1.8 trillion over 10 years, that is an average growth of 13%. 13% growth per year. There are not many economic sectors who have such a strong economic growth, and therefore space is really a domain where many different services and activities are developing. And what you see here on the screen are some of the examples in climate, in-orbit servicing, space connectivity, exploration, but there are also many others that are developing. And this is shown here on this graph, a different way of showing the growth. On the left-hand side, you see the increase of launches, both in terms of number of launches and mass. And on the right-hand side, which is quite interesting, is the growth from an investment point of view, so private investment coming into the space sector. Typically, when we as ESA develop a project, more and more we're asking for co-funding, or companies are co-funding projects. I name one example where we gave 25 million for phase 1 to a company to develop a LEO cargo return service. That means a service where you can bring 4 tons up to the space station, dock on the space station, unload, and bring again 2 tons down to the Earth's surface. It's a big project, as you can imagine. The first phase was only 25 million. The second phase will be funded by the end of this year. With this 25 million, ESA money, ESA contract, the company was organizing 150 million venture capital funding. And it is so important for these companies to have a contract with us, because that helps them going to a bank or going to an investment fund, venture capital funding entity, and then getting additional funding for this project. So there's a multiplier of 5, and of course we see more and more private investment, private fund flowing in. And on the right-hand side, you see exactly that. You see the volume, that means the amount of money, but also the number of deals that are being made in order to build up this economy. Also, commercialization, of course, goes in different domains to build up small launches, to build up this cargo return service, which I just mentioned. We have a big network, business incubation centers in all the countries. Altogether, we have 1,570 incubated companies so far. We have just celebrated 20 years of business incubation centers, and something that really creates a lot of added value and new companies that are coming on board. Earth observation, as I mentioned before, is one of the domains where we are good, where we are actually among the best, or if not the best in the world. And I'm not going to explain this diagram here, but just to say that we have 3 lines of Earth observation missions for science, for Copernicus, and meteorology. And you see all the number of satellites that are being developed. Most of them have flown already. The ones are being in development. And this really shows the depth and the strength of the European Earth observation system from different aspects, where we really measure these in the currently, but also in the near future. Very, very strong footprint of Europe, as I said, the largest in the world. Copernicus is exactly the program that does that. It's delivering, disseminating 250 terabytes of data every single day to different users in the world. It's the largest data dissemination system. I'm sure Telespazio sponsoring our cocktail is one of those enabling all this, but also very keen on further working on many opportunities that are coming up, because this is certainly something where Europe has strength and has quite a lot of expertise. Climate change, I don't need to explain the impact of climate change. Here are 2 images of 21 and 22. You all remember the drought, where quite a lot of the fields which usually are green. This is the same month, more or less the same day in summer when it was taken in 21 and 22 in July. And you see, of course, large of the areas of the continent and the UK here in brown, meaning that vegetation has been burning or has not been growing. Space debris is another point which is quite interesting. Actually, it's a big problem, and we monitor space debris. So what you see here is the number of objects depending on the size. So if you take the red number, which is 40,000 objects, these are objects that are larger than 10 centimeters. If you go down to 1 centimeter, then you have 1 million or more than 1 million objects. And if you go down to 1 millimeter, then you have hundreds of millions of objects that are floating in space. That's an issue. We have to do something about it, because these little objects, even if they're only 10 centimeters or 1 centimeter, they have a speed of 27,000 kilometers per hour, meaning they are like a bullet, and they could, of course, destroy spacecraft, they could hurt astronauts, certainly something that needs to be managed. This is an issue that is increasing in the future. I mentioned VGIL as another threat in space, if I may say so, which is monitoring. It is not yet launched. You see the launch is planned in 31, but it will monitor space weather. That means solar flares that are happening all the time, and what is the impact, and in order to really provide early warning of such events, of extreme events for us down on planet Earth. I mentioned rockets. Access to space is fundamental. That means no rockets, no satellites, no data from space. So that's why we have been working quite hard on the Ariane 6 and Vega C model, which I explained before. But we also have a new generation of micro-launchers that are being built up through a European Launcher Challenge, and they are coming to life. I think the first ones are probably not too far in the future this year, and several more will come in the next couple of years, and certainly something that is fundamental, and this is what we build up. This is a short video of the inaugural flight of Ariane 6 last year, which was such an important milestone, which I mentioned before. See now the separation of the booster. See now it's separating from the main station. So this was a very important moment. This is the fairing which is separating. You can imagine this was a very important moment. Of course, as DG of ESA, you are ultimately responsible on the success or not. The probability of a new rocket, the first time flying, to be successful is about 1 to 1. I did my statistics between 2002 and 2023. There were about 40 rockets that flew for the very first time. 47% of them failed. 47% failed. And these are big and small rockets. Of the bigger ones, all of them failed, or almost all of them failed. The Japanese H3, I don't talk about Starship, which still keeps waiting for the first full successes, but also India, China, even our own rocket, Ariane 5, the first 2 flights actually failed. The fact that this one succeeded is a big deal and is quite an important moment, and therefore we still celebrate it, as you see, more than half a year later. So coming back to what do we launch? We launch, of course, all the missions. I mentioned the Cosmic Observer. So these are missions that are looking at the whole cosmos, so not only the solar system, but really far out. I mentioned one of them, Euclid, which is measuring this dark energy and dark matter. But you see here there's a large list, and David used to be our director for space science, has created some of them, and has managed the development of some of them. So this is really your heritage, at least for some missions. But you see that Europe has a very rich spectrum of different missions. What you see here in the color in the middle is the different spectra that we are observing. This goes from the optical to radar to microwave and all the way to gravitational waves. On the very top, you have the ones in development. The second row is the ones flying right now, and at the bottom is the ones that have been flying, and they have been flying and deorbited, but the data are still being utilized because these data are serving the science community for decades, and they're quite unique material for Nobel Prize work, Nobel Prize research work, and many other discoveries that we do in our planet. Similarly, the Webb Space Telescope, I've mentioned it already. Something quite unique. Of course, the James Webb Space Telescope is led by NASA, just to be very clear, but Europe has had very strong contributions, 1.5 out of 4 instruments. The UK actually very heavily engaged in the science part, but also in the instrument development, and a lot of science has been already shown and developed, and much more will come in the next years to come. It was launched, as you see at the top left, with Ariane 5, which is quite remarkable. The telescope is worth about $10 billion US, and NASA has entrusted ESA to launch it on an Ariane 5 rocket. Everything went well, but you can imagine how nervous all of us were, because this is a very precious payload, and it went flawless. Actually, Ariane 5 and also Ariane 6 is known to be very precise in terms of orbit insertion. It was so precise that the lifetime of the James Webb Space Telescope was doubled, or more than doubled, thanks to the very good injection into the orbit, and therefore no fuel was needed in order to get it into the right orbit. This injection, this precision of injection was so good that the lifetime which was estimated at 10 years, is now more than 20 years, thanks to our launch with Ariane 5. And NASA is very grateful and very happy about that, as you can imagine. Solar system missions, similar a bit like the previous ones on the universe, but these ones, of course, looking at our solar system all the way from the sun to the various planets. As you see, we are studying all or most of the planets on our solar system. But more recently, of course, Mars is an object of intense study, but also Jupiter. We have a mission launched in 23 called JUICE, Jupiter Icy Moon Experiment, which looks at these icy moons for habitability on these oceans or on the icy moons, as I mentioned a bit earlier. So quite active, and Europe is really quite good and quite well known for its capabilities and the various parts of observing and measuring the different planets. This is an example of some of these activities. On the left-hand side, you see solar orbiter. You see the image as it changes. These are images as they come from spacecraft. The last one, so this yellow one, is quite remarkable with all these solar flares and There's another version, is not shown here, but there's an animation of these solar flares when you see them erupting. It's really quite active and quite a dynamic scene. Our sun is not a quiet spot. It's a power plant, literally, and it's really working. It's very active and very dynamic. You see the JUICE mission also in the middle here, bottom middle. ExoMars, another mission that explores the Mars surface to search for signs of life or signs of past life, and with a lot of discoveries as we found them. Space exploration, this is a bit of a topic that has been in the news quite a lot. So what is Europe doing? Of course, on the right-hand side, you see Mars exploration. You see the moon in the middle, and then on the left-hand side, you see the space station. You also see the distances on the bottom. They go from 400 kilometers to 400,000 kilometers to 400 million kilometers. So it's always a factor of 1,000 in between. If you go from the ISS to the moon to Mars, of course, the Mars distance depends on the constellation of planets. As you see, there's a large range, but this is the order of magnitude. And Europe is actually quite active on the various elements. Of course, we have all heard that the US has been proclaiming that they would like the stars and stripes to be planted on the Mars surface, which is quite a challenge, I can assure you. The moon is another domain where we expect a moon economy to develop with power plants, with drills, resources being found, being utilized, infrastructure being built, ramps for launchers being built. There will be an ecosystem developing. We already have a mission in development called Moonlight. Sarah mentioned it before, which will provide telecommunication and navigation on the moon surface, just like on Earth. With a mobile phone, you can make phone calls, you can navigate. We will do the same, obviously, on the moon, obviously used by different instrumentation. Argonaut is a mission that will transport about 1.5 tons of equipment, of experiments to the moon surface from Earth in order to start working there. So a lot will happen in the next decade, and a lot is being built up, including, of course, some astronaut missions, and this is something that is quite a debate right now, also these days as I speak, on what we should do, what Europe should do, what the US is doing, what China is doing, what Japan is doing, where we work together, where we want more autonomy, and this is certainly something that is quite interesting. Yeah, this is the goals for 25 and beyond. Actually, these goals, so the 5 goals you see here on the slide, are exactly the same headlines as they are in the 2040 strategy. That means our ministerial will be organized along those 4-5 lines of importance. Protect our planet, monitor climate, certainly a priority which we already have and we will further reinforce. Explore and discover. This is all the exploratory part, the science part, including astronauts, including space station, including Moon, Mars, and beyond. The third one is a new element, strengthening European autonomy and resilience. You could also call it defense and security. Certainly something that is existing but will significantly change over the next months, weeks, days, and years, and something that where we will build up our strength in Europe, our autonomy, very clearly. No need to explain why. Then the fourth goal is boosting growth and competitiveness, the whole commercial sector that is developing very rapidly in space, and we want to drive it forward with venture capital companies, with investors, to bring also private money into space, where we provide the frame as ESA, and private money helps us building up new activities, whether these are moon economy activities or in-orbit servicing or Earth observation, climate monitoring, or agricultural services, or emergency services, or even defense capabilities. Certainly this commercial market is a big domain that is coming. Last but not least, inspire Europe. Space has a very strong inspirational nature, not only the astronauts, but all things put together. I mean, here we are at one of the inspirations of humankind. Aeronautics 100 years ago was the space of today. I mean, 100 years ago, it was really planes that have been have been changing the world and have been changing human beings' interactions. And the next decade will be the decade of space, where space will change our daily life and whatever we do. And certainly this is something where inspiration is also an element where we are obviously working very strong. And with this, ladies and gentlemen, thank you so much for your attention.
Thank you very much, Dr. Aschbacher. If I can ask you one question about this question that the UK doesn't appear to be giving as many contributions to ESA than other member states, given the size of its GDP, and also given the return on the investment, which you've shown in the figures, which is exceedingly high. So if UK gives more into the European Space Agency, then it will benefit from the return on investment. But do you have a plan to get the UK to increase its contribution?
I mean, first I have a plan for the whole of Europe to increase. I've shown you on purpose some of the figures that may be a bit frustrating and a bit making you a bit sad if you compare European investment with, say, the US investment as an example. Europe has to catch up. This is very clear. Europe needs more autonomy, more strength, and a stronger space program. Having said that, Europe is doing a lot with the money we have, and it's almost incredible how much output we deliver. I've explained, I've shown you many examples. And yes, the UK is a very important country. I mean, there's so much capacity in terms of space technology, industries. We've heard one before more on the ground segment, but also space hardware industry, satellites. Service industry is actually the one where a lot of value is derived from space data for daily services, from agriculture to forestry to air quality to medicine to disaster management to security to defense, and many domains will really benefit from the use of space. And this is something that we would collectively want to develop. And yes, the UK is a very strong country. I would like to use the EXA Center as a symbol, as a center where this can be easier done because it's locally in the UK, but of course with all our ESA network and all our ESA centers and activities. And yes, the UK, I will speak to the new government, the new minister, state secretary in charge of space. I've met him already a few times, but this year we'll be sitting down, discussing what is the priority of the UK, seeing where the UK can best fit in the European context, complementing some of the other activities, and yes, defining projects together, and yes, encouraging investments. But I think what will make a big difference today, as compared to the previous ministerials, is the complete new geopolitical situation we have. Security defense will drive space a lot in the next years and months and years to come. And I think this is certainly a growth area. If I compare it with other countries and continents, Europe is actually quite unique in investing relatively little in the defense part. And there, I can give you figures. For example, the US, I've given you the figures for the US investment in space, which is about 80 billion per year. The defense budget is 800 billion, as you know. So space is about 1/10, so 10% of it. In Europe, the share, apart from the figures being smaller, but the share of defense, of space compared to defense is about 3%. So you see that there's enormous room for improvement, if I may call it. And I think also there the UK certainly has lots of strength, a lot of capacities, because space is dual use by nature. Almost all we do is dual use by nature, and this is something where ESA will probably also more and more work in the future.
Right. If I may, I understand that the White House is considering a 50% cut in NASA's science projects in the 2026 fiscal year budget proposal. What impact will this have on ESA's collaboration with NASA, for example, regarding the planned moon missions?
Yeah, NASA, I should say that so far we hear a lot of noise and a lot of speculation, if I may call it this way. Officially, NASA did not make a statement of any cuts yet, because The new administrator, Jared Isaacman, is nominated but not yet confirmed. He still has to do the hearings. We expect this to happen in the next weeks. But of course, when he comes then to be the new administrator, then of course he will define his new policies and new priorities. And then whether there are cuts or not, we have to wait. What you quoted is some articles that have been mentioned. I mean, we have also heard other things, that the space station would be deorbited in 2 years, and which, by the way, is not possible. But we hear a lot of these speculations. Some of it may come. We do not know yet. But officially speaking, nothing has been announced by NASA. So therefore, it would not be correct to speculate on speculation. So nominally, we have cooperation with NASA quite a bit in exploration. My message is always the same. We have agreements. NASA also depends on us, by the way. The European Service Module is the part in the Orion capsule which brings astronauts to the moon and back. In other words, without Europe, NASA cannot go to the moon with astronauts. And also we depend on NASA to bring our astronauts to the space station and eventually to the lunar gateway. So we have a mutual dependency. We are on track to deliver our contributions, and of course I expect NASA doing the same. And if things change, of course we will be ready for change. Right.
So I think we're about nearly 10 minutes behind schedule. So if you all agree, we could now go and have a cocktail, which is just on the ground floor. And I would like to thank you once again, Dr. Josef Aschbacher.
Thank you.
Thank you.